Hello, my name is Josh Larson,
And I'm Joseph Cheadle.
and we found an algorithm online to implement for recursive NFA.
This algorithm is, like you said, recursive, and as you can see, it accepts a state, and then going from that state, first of all, there's this for each loop here. This is checking all lambda transitions from that state. If any of those lambda transitions ends up in a final state, then you return true. If there aren't any, or after the lambda transitions are taken care of, we go through each of the, we read a symbol and check all transitions using that. And we check to see if going from state A to state B gets you to a final state. And if it does, it returns true, otherwise it returns false. And as you can see, that's a recursive call. If there wasn't a next symbol to read at all, we go into this else. And if the starting state was also a final state, then we return true, otherwise we return false. The advantage of this algorithm is that it is easy to understand and to implement. A disadvantage is you can get caught up in a loop with these lambda transitions and cause a Stack Overflow exception.
The implementation of this algorithm is shown here. We basically took the pseudocode and converted it to C#. We go through each lambda transition up here, and we basically create an object with a symbol property on it. When that symbol is null, it's a lambda transition or a lambda symbol. And so we process it and go recursively and return true if we can to accept it via the lambda transition. Otherwise, if we have more symbols to read, we go through and in this case we peek a symbol and see if that's a symbol that's used. If so, we take it and we process it. And then at the end, we check to see if we are in the final state, and if we are, we return true and we accept the string. The two green rectangles indicate some improvements that we made or some misinterpretations of the algorithm to make it accept strings using the second machine that we'll discuss soon.
So here we are going to demo our implementation. We have two different NFAs that we have created. One is a basic one that will accept a single string of AB, AB. And so there's only one final state and only one way to get there. The second one is a more advanced machine. It will accept an empty string, and it will also accept multiple A's and then ending with a B. So here we have our program. I'm going to choose machine 2, and I'm going to enter a string so we can see AB will not be accepted, and something with a lot of A's then ending with one B will be accepted. An empty string is also accepted.
As we said before, this algorithm is susceptible to Stack Overflow failures. This example here shows a lambda transition cycle where you can go from Q0 to Q1 then back to Q0. With this algorithm, the way that we implemented it, it will actually cause a Stack Overflow and it will continue to take lambda transitions forever. We decided that a fix for this, you could implement a way to detect that loop and use an alternate walk instead and basically track that path and dictate that it doesn't get you anywhere and then move on.
So what we learned from this is that there are those limitations to always taking that lambda transition first. So there would need to be a way to break out of that in a real implementation of this. And we also learned that the implementation of an NFA can be easily implemented using an object-oriented programming technique.
Lastly, we had to make one adjustment to the algorithm to support the idea of peeking a character or a symbol and taking it. This was used for the second machine. If you were to use the string AB, it would start using lambda transitions, consume the A, and then it would kind of ditch that path, go back, and then you would have taken that A character. So instead we use peek to see if that path is actually taken, and then consume the character at that point. That was how we got the machine to accept AB.